Welcome again to Math 800 Pre-Algebra. Today we are doing section 5.6, Fractions and Decimals. Our objectives: 1. To write fractions as equivalent decimals, and 2. To compare the size of fractions and decimals. To write a fraction as an equivalent decimal, divide the numerator of the fraction by the denominator. If necessary, round the answer to the place value indicated. Write 1/8 as a decimal. 1/8 is the same as saying 1 divided by 8. That means 8 will be on the outside and 1 will be on the inside. You must have this order correct. If you get these two things swapped, you will get the wrong answer. 8 obviously can't go into 1, so we're going to have to put a decimal and some zeros. The decimal goes right after the ones place, and it comes straight lined up, as always. I'm going to start adding zeros. 8 can't go into 1, so then we add a 0. 8 goes into 10 one times. 1 times 8 is 8. We subtract that and get 2. Add a 0, drop it down. 8 goes into 20 2 times. 2 times 8 is 16. Subtract that and get 4. Add a 0, drop it down. 8 goes into 45 times. 5 times 8 is 40. Subtract that and we get 0. We had to add 3 extra zeros in this case, but we finally got a remainder of 0. Remember, you have two goals in mind. You want to run out of digits and get a remainder of 0. If you haven't gotten a remainder of 0, you just keep adding zeros till this happens or until a pattern starts to emerge. In this case, we finally got a remainder of 0, so we're done. So 1/8 is equal to 0.125. These are equivalent. One is in fraction notation, one is in decimal notation, but they mean the same thing. You can always check your answer by rewriting 0.125 as a fraction and then simplifying it. 0.125 is 125 thousandths. Remember, we're in the tenths, hundredths, thousandths place. And then you can simplify this by dividing both the top and bottom by 125, and you get 1/8. You need to be able to go from fractions to decimals and from decimals to fractions, back and forth, so you must be familiar with going both directions. Another example. Write 2 3/4 as a decimal. We have two options for doing mixed numbers. One is to leave it as a mixed number, and recall that 2 3/4 is the same as saying 2 plus 3/4. Mixed numbers are just an addition between a whole number and a proper fraction. We will now convert the proper fraction 3/4 to the decimal. 3/4 is 3 divided by 4, so the 4 goes on the outside and 3 goes on the inside. Add the decimal after the ones place. 4 can't go into 3, so we're going to add a 0. 4 goes into 37 times. 7 times 4 is 28. Subtract, and we're going to get 2. Add a 0, bring it down. 4 goes into 25 times. 5 times 4 is 20. Subtract that and get a 0. We have finally gotten a remainder of 0, and we're out of digits. Therefore, 3/4 is 0.75. We know that 2 3/4 is 2 plus 3/4. We've just found out that 3/4 is 0.75. Therefore, 2 3/4 is the same as 2 plus 0.75. Add them up. Remember, when you're adding decimals, you need to have your decimals lined up, and there's always the decimal after the ones place, so it's right there. Therefore, 2 3/4 is equivalent to 2.75. Again, you can check this by converting back to the fraction and then simplifying it. But in this case, our answer is 2.75. These checks you do not have to show me. I am not grading them. However, it is a good idea for quizzes and exams to check your answer before you turn it in. I would, however, wait until you have finished all of the problems before you do the checks. There's a second way we can convert 2 3/4 to a decimal. That is to rewrite the mixed number 2 3/4 to the fraction. So 2 3/4 is the equivalent of 11/4. 4 times 2 is 8. 8 plus 3 is 11. Now we will do this long division. Remember, 11/4 is 11 divided by 4, so 4 goes on the outside, 11 on the inside. 4 goes into 11 two times. 2 times 4 is 8. We subtract that and we get 3. Normally we would quit and we'd say 2 with a remainder of 3. Or, notice the 2's and then the remainder of 3. However, now we want to go all the way into decimals, so we're going to start adding zeros and bringing them down. 4 goes into 37 times. 7 times 4 is 28. Subtract and get 2. Add another 0 and bring it down. 4 goes into 25 times. 5 times 4 is 20. Subtract and get 0. And so we get the same answer, 2.75. I'm okay with either method. you can either leave it as leave it as a mixed number, or you can convert it to an improper fraction. You get the same answer regardless. Write 2/3 as a decimal. So 2/3 is 2 divided by 3, which 3 will go on the outside, 2 will go on the inside. Again, order is really important. 3 can't go into 2, so we're going to start adding a decimal and start filling in zeros. 3 goes into 26 times. 6 times 3 is 18. Subtract and get 2. Going to add a 0, bring it down. 3 goes into 26 times. 6 times 3 is 18. Subtract and get 2. Add a 0, bring it down. 3 goes into 26 times. 6 times 3 is 18. We're going to subtract and get a 2. Notice this pattern continues. This pattern will continue over and over and over again. It will never end. This is an example of a repeating decimal. Remember, I would like you to write your repeating decimals with the little bar over the number that is being repeated. This is how I would prefer your final answer to look. However, sometimes you'll be asked to round. In this case, let's round to the nearest 10,000th. To round to the nearest 10,000ths, which is in this third spot, you actually need a fourth decimal so that you can determine whether the 6 will stay a 6 or round up to a 7. Now that we have our fourth decimal, we can see that it's greater than 5, so this is going to round up and be approximately 0.667. This is the answer I would prefer. However, sometimes they will ask you to round. Make sure you read your directions very carefully. Now we will get into Objective 2, comparing the size of fractions. Below are two number lines that can be very helpful. I want to quick note some important fraction and decimal combinations that I would highly recommend you memorize. The first is that 1/2 is the same as 0.5. Most of you already know that. The second set would be 1/4 and 3/4. You should have memorized that 1/4 is 0.25 and 3/4 is 0.75. And lastly, I think you should have memorized that 1/3 is 0.3 repeating and 2/3 is 0.6 repeating. These fractions come up very frequently, and so if you can have them memorized, you will save yourself a lot of time and a lot of effort. Okay, we will use a number line to help us check, but we want to compare 0.6875 and 0.625 and determine which one is larger. Basically, you're asking which one is on the left or the right on the number line. Numbers on the left are smaller, numbers to the right are bigger. 0.6875 is going to be on the right of 0.625, so it is the bigger number. We'll use the greater than symbol. Another way to think about this is if this was money, it's not a lot, right? This would be a little more than 68 cents, and this is a little more than 62 cents. But 68 cents is still more than 62 cents, so this is the bigger number. On the number line, we can see that 0.6875 is on the right of 0.625, therefore it is bigger. We use the greater than symbol. Here is your final answer. 0.6875 is greater than 0.625. Compare 0.75 and 3/4. This is one of the ones I told you to have memorized, and so hopefully you realize that 0.75 is the same as 3/4. Here they are on the number line. So we just use the equal sign and say 3/4 is equal to 0.75. Compare 0.5 and 0.5 repeating. At first glance, they seem the same, but remember 0.5 repeating means that you have multiple 5s going on. So if we were to round this to change, this is exactly 50 cents. This, however, is a little bit more than 55 cents. 55 cents is bigger, so therefore 0.5 is to the left and 0.5 repeating is to the right. It is the bigger number. So 0.5 is less than 0.5 repeating. On the number line, here is 0.5, and 0.5 repeating is just a little bit bigger. It's just on the other side of the number line. So 0.5 is less than 0.5 repeating. If you need to write your repeating decimals with the several decimal points written out and the ... to help see which is bigger and which is smaller, feel free to do that. Now we're going to write the following numbers in order from least to greatest. When comparing decimals, it is often easier to have all the same decimal places. So in this case, I'm going to rewrite all three of them with 4 decimal places. 0.49 can be written as 0.4900 or 4,910 thousandths. 0.487 can be written as 0.4870 or 4,870 ten thousandths. And 0.4903 already has 4 decimal places. That's 4,903 10,000ths. Now that they have the same number of decimal places, it's easier to see which one is smallest, namely 4,870 10,000ths is smallest. Next smallest would be the 4,900, and then the biggest would be the 4,903. So in order from smallest, from least to greatest, is 0.487, then 0.49, then 0.4903. Write the numbers in order from least to greatest. Here's another example. 2 5/8, 2.63, and 2.6. You can't compare fractions and decimals in their various forms, so we're going to have to convert. Sometimes it's easy to convert the decimal to a fraction. However, you would need a common denominator in order to compare them, so it's usually easier to convert the fraction to a decimal. So 2 5/8 is 2.625. So now we'll write all of the other two decimals with 3 decimal places so we can compare. 2 5/8 is 2.625, which is 2 and 625 thousandths. 2.63 is 2.630, they're the same, which is 2 and 630 thousandths. And 2.6 is the same as 2.600, which is 2 and 600 thousandths. From here it's clear that the 2 and 600 thousandths is the smallest, followed by the 2 and 5/8, or 2.625, and then the biggest is 2 and the 630 thousandths. So from least to greatest we have 2.6, 2 and 5/8, and 2.63. That concludes section 5.6. Your next steps are to complete the worksheet for section 5.6, then check the key in D2L, and lastly complete the online homework for section 5.6 through my math lab.